We, of course, live in a very data-driven world, and so it's really important that we have ways to be able to organize and analyze our data, and matrices give us one such way to be able to work with data. So what a matrix ultimately is it's going to be a rectangular arrangement of your data that you want to have organized. And so because it's rectangular in nature, basically your whatever the data is, whether it's numbers or things that are more qualitative in nature, are going to go into rows and columns. So it's a rectangular arrangement of data into a series of rows and columns. So let me give you an example of a matrix. Now, it's important that you understand that when we're dealing with matrices, we usually name matrices using a capital letter from the English alphabet. So I'll denote that here. So yeah, matrices are usually named using a capital letter. So I'm just going to pick a random letter from the alphabet. So let's say J, capital J. So if we're going to name matrix J, then I'm just going to kind of make up a matrix right here. And then, so I'm just going to make up some data as well to put inside of the matrix. All right, so that gives us an example of what a matrix might look like. So we are going to specify some characteristics of the matrix. So one such thing that we specify about the matrix is what we refer to as the dimensions of the matrix. Now there's some other terms that we can use alongside dimensions as well. So sometimes we might refer to the size of the matrix, or we might also refer to the order of the matrix. And all three of those terms, they mean the same thing. So ultimately the dimensions are telling us how many rows and how many columns the matrix contains. So for our particular matrix J, I'll just say dimension of J. So the dimensions of J, in this particular case, you always say the number of rows first. So since we can see that there are 3 rows, then the dimensions of J will be a 3 by, and then you can see that there are also then 4 columns. So the dimensions of it would be 3 by 4. Not 4 by 3, because that would be reversed. We'd have 4 rows and 3 columns. So you always put the row number first and then the column number second to specify the dimensions of a particular matrix. And then we also denote the elements, or another word that we use alongside elements is the entries of a matrix. So those two things mean the same thing as each other, and those really are just going to be the individual elements inside of the matrix, or the individual data entries in a particular row and column position. So when we denote them as such, we're going to use a lowercase version of the name of the matrix. So since we named the matrix with a capital J, then we're going to use lowercase j's to denote specific positions of matrices, of elements in matrices. So you'll see, like, if this matrix was called capital A, then you can see, like, for example, right here, we would denote that element by the name of lowercase a, and then it has like a 3 and a 1. Does not mean 31. It's just that the first number 3 tells you what row it's in, and then the second number, the 1, tells you what column it is in particular. So like if I pick the example matrix of J that we picked right here, then if I were to indicate what J32 is, okay, then I'm really looking for what row I want the element to be in, and then the column that I want this to be in. So I'm looking for the element that's in the third row and the second column. So since the third row is there and the second column is there, then J32 is equivalent to the number 11, because that's the element in that particular position in that matrix.